In this video, I want to take a look at how we can use the computer to help us graph direction fields much more quickly and accurately than doing it by hand in the way that we did in the last video. And so I want to look at the exact same equation. I think this was the second example in the previous video that we looked at where we drew this by hand. And I want to see how we can draw a direction field using computer aids. The first one I want to look at is using a program written in Java. I think I mentioned in the last video that I was going to have three ways to do this, that there's a way to do this in MATLAB, another program that is very similar to the one in MATLAB that's been written in Java, and then the third option is doing it using Desmos, which, if you're not familiar, is basically an online graphing calculator. Well, it turns out, as I have investigated this further, the MATLAB option no longer works. The function that was written is incompatible with current versions of MATLAB. It works if you have an older version of MATLAB, say like a 2015, 2016 version, but it doesn't work for the new 2020 version of MATLAB. So I'm nixing that one. Instead, we're just going to look at two approaches. So the first one I want to look at is using this program in Java. So let me open this folder. I've attached these files for you. This one is, I don't know why it's showing up as an Adobe Acrobat file. It is not an Adobe Acrobat file, but I will provide these for you that allow us to run this program. The only thing you will need is to have Java runtime environment downloaded on your computer. And so I'll give instructions for how to do all of that in some accompanying text that goes along with this video. But basically, download what I provide, put it in some folder, just even on your desktop if you want, and all you'll need to do to get this running is click where it says Run dfield. So double click that. If you've got a Windows machine, at least this should work. I haven't tested it on a Mac, but that's the idea. Okay, and it'll give you this big spiel about how this was developed. It was originally developed in MATLAB, and people have since rewritten it in Java. So click OK and get rid of that. And you'll notice right away it gives us a big picture of a direction field. And to understand exactly what's going on here, this picture is the direction field for this differential equation up here. X prime equals x squared minus at plus b, where it's presumed that t is the independent variable and x is the dependent variable. We can change that over here. So over here is where we can write our variable. If I want to write it in the same notation that we're used to using, usually we will use y as the dependent variable. So let me delete all of this and delete this up here in the left-hand corner. And let me type y in. So we're going to be solving y prime equals something. And so all I need to do is write down, move all of this is coming up in the background. Let me just get this piece so we can see that. Oh, come on now. I want this piece, and where did I put all the other stuff? The editor here. Okay, maybe this will work. Okay, this will kind of work, so we can kind of see all of this at once. So here's the equation that I'm wanting to replicate. dy dx equals x over y. So here's my dy dx, it's y, and right there is the little hidden prime. So this is y prime on the left-hand side, and all I need to do over here is write x over y. And it's giving me an error right now because we have the independent variable listed as t, and I'm not using t, I'm using x and y. So in our case, the independent variable is x. And it should fix everything. Down here, we can now change the window that we want to look at. You'll notice right now it goes from x values of -2 up to 10, y values from -4 to +4. Let's just do a nice square window where I go from -4 to 4 in both the x direction and the y directions. And if you want to involve parameters that you can change down the line, you can do that, but ours doesn't have any parameters. There's no constants a or b included here, so we don't need to worry about this portion. So let me just hit graph phase plane, and we should get a picture of this particular direction field. So let me hit that button, and sure enough, we get a picture that looks a lot like the one that we did in the previous video. And if I want to see one particular solution, I can go find an initial condition. So say that I know that the solution that I'm interested in it goes through the point y equals 1 when x is equal to 0. So all I would have to do is go to where x is equal to 0 down here and go follow that line up to where y is equal to 1, which is right here. And if we click right there, it will draw in the particular solution associated with that initial condition. And if you just start clicking all over the place, you'll see that we can start to get a bunch of different solutions. Remember, we had an issue, so it's giving me a message here. And notice that this one graphed, and it came all the way down, and as soon as it got to the x-axis, it stopped. Why did that happen? Well, we discussed this previously. Our equation right here is going to be undefined. The slope is going to become undefined when y is equal to 0. So when it hits the x-axis, which is also the line y equals 0, anywhere along this line, it'll stop graphing it, and it's basically just spitting out, in a sense, an error saying, hey, we can't go any further. We've gone vertical, essentially. And so we can click a couple more solutions. It'll give us that same issue. We can do some up here, some down here, do one down here. And you can get a bunch of different solutions that go through any particular point of interest that you want to click on. So let me hide all of these. So that's how we can use this. It's a really useful thing. And if we want to change this, maybe I'm interested in y prime equals, I could do y times 1 minus y and see how that looks. And let me see, I don't know if it'll give me an argument and complain that I didn't write the time symbol in here. So let's just take a look and see what that does. Let me graph that and see if it does it. Okay, no problems there. So here is y prime equals y times 1 minus y. And again, I can click on solutions, and I can get some pictures that kind of give us the behavior that we're looking for. And this differential equation is actually very similar to the logistic growth equation we did where we were doing population growth problems. And it's similar to the one that we looked at critical points and stability of critical points on. We looked at one very similar to this. I didn't use the number 1 here. I think I had A and B at various points in here instead. But same idea. So we can use it to really get a good sense of what the solutions look like by just clicking, and it also gives us the direction field. So ideally, this Java version is nice because you can click and it'll draw these solutions. I'm going to show you the version that we can do in Desmos in just a minute. It's also it's easier to use than this one here because you don't need to download and install anything. But it doesn't have this nice feature where you can click on the graph and it'll draw in a solution for you. So weigh those two things as you see fit, as you decide which one you want to use. So let me close this one, and let's quit dfield, and let me open this one. So here is Desmos, and I will give you a link to this particular one. But basically, all I did was go on Google and search Desmos direction field, and this was one of the first two that showed up. So it's very similar. It says right here, let g of x comma y equal dy dx. So it's basically saying we have some function g of x, y that is the same as our dy dx. So we've got something that looks like this, dy dx equals to some function that they're calling g of x, y. And this one by default had this typed in. The only thing I'm going to do is make it look exactly like ours is delete that too. And it'll instantly change, and you will see now the same direction field that we just had a minute ago, but notice I can't click on it and have it draw solutions. It'll kind of highlight stuff for me. One thing we can do is move this little point around, and it'll compute the slope at any given point that we want to put it at. So you can move it wherever you want, and it'll draw the slope at that particular point. But it will not graph individual solutions. So you don't need to mess with where it says the movable point or slope grid, but you can go in here into these and modify it and kind of play around to decide how many of these little hash marks you want it to draw and what the range is if you want it to, instead of going from -10 to 10. you can go adjust all of that. But same thing, we can come in here and delete this and change it to the same one I did a minute ago, y times 1 minus y. And sure enough, we get something that looks kind of similar to what we had before, but there's not much detail as we go into these points that are kind of closer in here. So maybe if I do 5 minus y, it'll be a little more clear. We can kind of see the behavior that's going on. Even that is kind of wonky. Let's try 3 minus y. But basically, you can graph these all you want. You can change the g of x, y that you want to use, and it'll update the direction field for you. If I come in here and we change which points we want it to graph it on, you can change. So you can see they've basically manually done this. It's not very elegantly coded, but it is what it is. But you can change, instead of going from -10 to 10, you can maybe I just want to go from -5, -4.5, comma, dot, 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 up to 5. And it will, now instead of going by in increments of 1, it'll go in increments of a half instead. Let me see if I can get that to go. And we can again kind of zoom in and see what's going on a little bit more clearly as we zoom in. So that's one way we can do this. Did that even work? I guess it's still doing them in increments of 1. Well, that's frustrating. Okay, I guess you can't make it go at increments of a half. Doesn't look like it, at least. So we'll just stick with that. But just know that you can use this. There's other ones, and again, if you just Google Desmos direction field, there's different ones that you can look at and play around with. But I definitely would recommend using these in general over graphing a direction field by hand. And more than this, if you're willing to spend a few minutes installing some software and installing the Java runtime environment on your computer, which is totally free and basically is what you would need to install if you wanted to start learning how to computer program in Java. If you install that and download the files that I provided, that Java version is a little bit nicer and easier to control once you have it installed. So if you have any questions about this, don't hesitate to reach out. And I apologize that the MATLAB version is no longer working. You can see I have it downloaded down here. I was just playing with it and could not get it to work. So for the meantime, 2 options, Java or Desmos. Pick whichever one you want to use, and hopefully you can start to play around and get a sense of what direction fields look like for all sorts of different differential equations.